charged ions are known as anions. So we have oxygen, sulfur, selenium, telluronium, and polonium.
The S is sulfur.
These are known as the chalcogens. Next to that, you have the group 7A elements, or group 17. And you have fluorine, chlorine, bromine, iodine, or iodine, and acetine. So these have 7 valence electrons, and they like to form -1 charges. So as ions, it's fluoride, chloride, bromide, and iodide. O with a negative charge, or -2 charge, is oxide, sulfide, selenide, and so forth. The halogens are the most reactive nonmetals. As we said before, metals,
these are called halogens.
So metals they form good
not the halogen light.
Non-metals like to accept or acquire electrons. So non-metals are usually good oxidizing agents. Non-metals like halogens are very, very reactive. Fluorine is the most reactive non-metal. Francium is one of the most reactive metals, which is on the other side of the periodic table. Below cesium, the alkaline metal, you have francium. Because fluorine really wants to have electrons, it is electronegative. Electronegativity increases towards fluorine. So as you go up and as you go to the right, electronegativity increases. So what this means is that fluorine has a very strong desire for electrons. Fluorine's desire for electrons is greater than that of oxygen and chlorine. So nonmetals tend to be electronegative. Metals are usually electropositive. Electronegative elements, once they acquire the electrons that they want, they form negative charges. Electropositive elements like metals, they like to give away electrons and they're going to develop a positive charge. Now, group 8A, or group 18, this represents the noble gases. So, over here you have helium. Helium has 2 valence electrons. It doesn't have 8. The first row elements, they can only have a maximum of 2 electrons in their first energy level. Elements in the second row can have up to 8 electrons in their energy levels, or in their second energy level. Neon has 8 valence electrons. And then below neon, you have elements such as argon, krypton, xenon, and radon. The noble gases are chemically inert. They're very stable. They don't really participate much in chemical reaction.
Ne. It have 8 electrons, so you could taken from
8 electrons in the outermost orbit.
Then helium outermost is only
2. Because in the first orbit, only 2 electrons can accommodate.
So if you get a test question and it asks you which element is non-reactive, carbon, nitrogen, fluorine, or neon, your answer is neon.
ये 4 में कौन से नॉन रिएक्टिव होंगे? आंसर इज नियॉन.
Now let's see if you get a question that asks you which of the following elements is or shares the same chemical reactivity or is most similar chemically speaking.
Tell.
Let's say we have nitrogen, oxygen, sulfur, fluorine, and neon.
Out of these 5, which shares the same reactivity, chemical reactivity?
means
0. Oxygen and sulfur.
Why?
Because they both have -2.
Correct.
Whenever you have 2 elements in the same column, they share similar chemical properties. So in this case, oxygen and sulfur are chemically similar because they're both chalcogens.
Out of these 3, which has more reactivity?
It has more reactivity.
and
Chemical reactivity.
This F. One say N, one say O, one say F. Finish. One will be right.
And
Why?
because it has more electrons.
No.
No, less.
Wrong. F will have more reactivity, fluorine. Reactivity increases in this direction and in this direction, because this has to take 3 electrons, correct, and this has to take only 1 electron.
In the same column. So fluorine and chlorine are chemically similar to each other. They're both halogens. They have the same number of valence electrons, and so their chemical reactivity is similar. Now you need to know where the metals and the nonmetals are with respect to the periodic table. So if you look at a typical periodic table, you're going to see like a line, which goes like this.
In that table also.
Where? Oh.
These are metals, these are semi-metals, and these are non-metals. These are inert gases, these are non-metals.
So sulfur is not metal?
Sulfur is not metal.
To the lower left of that line, you have metals. On the upper right side, you have nonmetals. So elements like oxygen, fluorine, sulfur, chlorine, these are all nonmetals. The elements like indium, gallium, lead, aluminum, those are metals.
Metals are defined as metals will give away electrons, they will not take electrons.
And then in between you have
Tend
metalloids.
to posit
The most common metalloids that
positive
you'll see in chemistry are silicon and germanium. Those are the most common metalloids that can be tested on.
metalloids. These are called metalloids.
Metals conduct electricity. Metals can also conduct heat as well. Metals are malleable, they can be hammered into sheets, and they're ductile, they can be drawn into wires.
These are 4 properties of metals most commonly understood. Metals are electrical conductors. Metals are thermal conductors, means they conduct heat. हीट को पास होने देते हैं, उसको कंडक्ट करते हैं, इलेक्ट्रिसिटी को कंडक्ट करते हैं. दे आर मेलिएबल, मतलब यू कैन बीट देम टू मेक रोल और बीट देम इनटू शीट्स. ऐसे रोलिंग करके उसकी शीट बना सकते हैं पतली पतली. एंड दे कैन बी ड्रॉन इनटू वायर्स, दे आर कॉल्ड डक्टाइल. डक्टाइल मीन्स दे कैन बी ड्रॉन इनटू वायर्स. उसको इफ यू ड्रॉ दैट आउट ऑफ स्मॉल होल, then it will be converted into wire. Then you can make that wire thin or thick or whatever. This is called malleable property. So metals have these 4 properties. Besides that, it has luster, means it will be shining. Metals will be shining, and normally at a normal temperature and pressure, normal conditions, it is always solid, except one metal, which is mercury. All other metals are solid at normal temperature.
Nonmetals do not conduct electricity. Metalloids, they conduct a small amount of electricity.
Metalloids, they conduct electricity to some extent, not fully. Small amount of electricity. Silicon, which is widely used for solar cells.
Silicon.
That's a semiconductor.
But that will finish. Yeah, when solar energy will go by that, so silicon will finish.
Metals are insulators, metals are conductors. Metalloids, they're conductors but with a very high
Non-metals are insulators, metals are conductors, and metalloids are in between.
resistance or electrical resistance. So metalloids, they conduct only a very, very small amount of electricity. Now, which metalloid do you think conducts more electricity, silicon or germanium? As you travel to the left and down across the periodic table, the elements become more metallic. Metallic character increases this way. So which one behaves more like a metal? Silicon?
As you go in the periodic table this way, metallic characteristic increase, and down, metallic characteristic increase. That means this has more metallic characteristic than this. This has more metallic characteristic than this. This has more metallic characteristic than this. So in the table, in this way, metallic characteristic increase. So which one is having more electrical conductivity? Silicon or germanium?
Germanium.
Why?
Because it is under the silicon.
Because metallic characteristic increase in the down direction. So it is in the same column, but it is in the next period, which is down. So that means it will have more metallic property, and metallic property is electrical conductivity.
Or germanium. So carbon, for the most part, is considered to be a nonmetal. Silicon and germanium are metalloids. Tin, think of a tin can. Tin metal, well, tin is a metal. Lead is a metal. So as you go down across the periodic table, the elements are becoming more metallic, which means that the electrical conductivity is increasing. So lead can conduct electricity better than tin. Tin metal can conduct electricity better than germanium. So germanium, even though it's a metalloid, can conduct electricity better than silicon because germanium has more metallic character than silicon. Now carbon has different forms, known as allotropes. Carbon can be in the form of diamond, which does not conduct electricity at all.
Carbon
but
is an
diamond
exception.
is an excellent conductor of heat. Or
Carbon can be in the form of diamond, which doesn't conduct electricity, but conducts very nicely heat.
be in graphite, which you can find it in pencil lead.
Or it can be in the form of graphite, which you see in pencils.
Carbon graphite does conduct electricity,
Graphite conducts
so make
electricity.
sure you're aware of that. So the metalloids are silicon, germanium, arsenic,
वो अंदर क्या होता है
वो मैंने
Graphite.
सिलिकॉन
antimony, Te. Boron, for the most part, is considered to be a metalloid, but the most common are silicon and germanium.
silicon and germanium also.
Now, the next thing that we need to go over are the diatomic elements.
Okay.
Hydrogen,
Discuss diatomic.
in its natural state, doesn't exist as H. Hydrogen exists as H2. It's diatomic. So it exists as a molecule. Nitrogen is diatomic. Then you have oxygen, fluorine, chlorine, bromine, and iodine. These are all diatomic. And this is something you just have to know. Hydrogen is a gas at room temperature. Nitrogen is a gas. Oxygen is a gas. Fluorine is a gas. Chlorine is like a greenish gas. Bromine is a red liquid.
Red liquid.
And iodine is a purple
solid.
volatile solid.
Volatile
Iodine,
solid.
under normal standard temperature and pressure conditions, even though it's a solid, it can sublime directly into a gas.
Iodine has a specific property.
Whenever
It can in a normal temperature pressure it can sublimate into gas. Means वो बीच में से liquid phase नहीं आएगा. Directly from the solid it will become gas. That is called process of sublimation.
a substance go from a solid to a gas, it's known as sublimation. So make sure you know your 7 diatomic elements.
Process of going from solid to liquid is melting. Liquid to gas is boiling. While solid to gas is sublimation.
Now the next thing that we need to go over are bonds, covalent bonds and ionic bonds. So what exactly,
Condensation is
Is
from
an ionic
gas
bond.
to liquid.
and what is the difference between a covalent
Is
bond and
sublimation.
ionic bonds? Consider the reaction between sodium metal and chlorine. So let's say if we have an atom of chlorine as opposed to a diatomic molecule. Sodium has 1 valence electron and chlorine has 7.
These are number of valence electrons. It is denoted like this. Element, atom, and how many electrons are there in the valence orbit that are shown by the points.
Valence electrons. Now, as we mentioned before, metals, they like to give away their electrons. Non-metals like to acquire electrons. So sodium is going to give
Sodium.
away its 1 electron to chlorine. When sodium loses that electron, it becomes a positively charged cation. Chlorine, on the other hand, now it has 8 valence electrons. and so it becomes a negatively charged anion. Whenever you have two like charges next to each other, these two will feel a force that repels them. Opposite charges, well, like charges repel, but opposite charges attract. Now sodium, it has a positive charge. Chlorine has a negative charge. So these two ions, they feel a force of attraction that keeps them together. It is that electrostatic force of attraction that holds the ionic bonds together. So remember, ionic bonds are associated with a transfer of electrons. They're composed of ions that are attracted to each other, and also, typically, not always, but generally speaking, you can identify them because they contain a metal and a nonmetal. Whenever you mix a metal and a nonmetal together, they react in such a way to form ionic bonds. Now, in a covalent bond, the electrons are shared. For example, let's say if we have two hydrogen atoms, each with one valence electron. These hydrogen atoms will react in such a way to create a bond. And in this bond, there are two electrons. Those two electrons are shared between the two hydrogen atoms. And so this is a covalent bond since we have sharing of electrons. Now, because the elements are identical, because they have the same electronegativity, this is classified as a nonpolar covalent bond. Because the electrons are distributed equally, it's nonpolar. Now, let's say if we have two dissimilar elements. For example, hydrogen and fluorine. Now, these are both nonmetals. Two nonmetals typically form a covalent bond. Now, hydrogen is going to donate one electron to form the bond, and fluorine is going to donate one. So HF looks like this. Now, fluorine is significantly much more electronegative than hydrogen. So fluorine is going to pull the...
What will happen? Who will be?
They are forming a covalent bond, sharing two electrons.
electrons toward itself. So because the electrons are shared unequally,
What will be the attraction? What attraction will be there? What will be the charge? That charge. कितना charge होगा दोनों?
No, this is covalent bond. So in covalent bond, that is not ionic bond. Ionic bond is positive and negative. They are sharing electrons.
the bond is going to be considered a polar covalent bond. As fluorine pulls the electrons toward itself,
Anyway,
it's
this
going
is
to
detail you
acquire
don't need to
a
know.
partial negative charge. And hydrogen, since it loses some of those electrons, it's going to acquire a partial positive charge.
What is it?
Whenever you have a
It's
neutral
not,
molecule,
it's
but
partial.
where one side is partially positive and the other is partially negative, you have a polarized substance.
You don't need
You
to
have
know
a
this.
dipole. To draw the dipole, the arrow has to point towards the more electronegative atom. The electronegativity of fluorine, if you look it up in the table, most textbooks would say 4.0, and for hydrogen, 2.1. Whenever the electronegativity difference, if it's greater than 0.5, or if it's equal to or greater than 0.5, the bond is considered to be polar. If it's less than 0.5, it's usually nonpolar. So whenever you have separation of charge within a molecule, you have a polarized molecule. Now consider this bond between carbon and nitrogen. Do you think this bond is
Okay,
polar
I
or
think
not?
now this is going to be in much more detail. Now they are entering polar covalent, non-polar covalent. There will be discussion of poles. So this is basic explanation of the periodic table. How different elements are there.
Chemistry.
from, so this is like very basics, that these are the elements. Some of the names you may know, and that's it. Nothing more. So now three things I will explain, and then we will end. Some
Yeah.
there are some are called, see, acid metals and non-metals we saw. What are metals? So metals, they usually
Metals, huh? Metals and gases.
metals. What are metals and what are non-metals? That we saw. Now there will be acids, bases, and salts. Acids react with bases to form salt and water. This is one definition of acid or base. Two types of elements, acids and bases. So acids are those which can donate electron. Elements which can donate electron, or you can say when they are mixed in water, they can form H positive ions. And bases are those which accept electrons.
What are you doing?
There is not coming.
Akshay, don't play.
I am not playing.
What not coming?
There's a part upside.
Everything is coming.
You are not coming. Say it like this, no? You are.
Yes,
Yes, is not coming.
That's what I was confirming.
Hey.
Yeah, acid is a species that can accept electron pairs from coordinate covalent bond. Base is any species that can donate electron pairs. Base will donate electron. Acid can accept electron. Base is donate electron. This is a basic definition of acid and base according to chemistry. Otherwise, in a layman's language, acid's definition will be that acid is a chemical which, if dissolved in water or in liquid form, it can turn red litmus paper, blue litmus paper to red.
We can do more surviving because many things are left and so when we will go?
Just quickly finish them and come.
When is such
Now, 12 o'clock.
12 o'clock, Satchidanand Pushkar.
Means now chapati all is left.
Only 5 minutes are left for the
10 minutes are left. So you can come little late, 5 minutes late you can come now. Go and serve them. So it turns blue litmus paper to red. Litmus paper is one type of paper they have developed. So if you touch litmus paper to acid, then it will turn blue litmus paper to red. While if you turn blue litmus paper to base, it will red litmus paper to base, it will turn it into blue. This is a layman's definition. You can check acids like this, bases like this. Acids will generally have sour taste. Khatta.
So it's like vinegar.
Just like I am am not tasting it.
My father is just.
Sour is just like lemon. Lemon is sour. And they are usually electrical conductor. And they will react with metals. Acid will heavily react with metals to form H2, means when acids fall on metal, then gas will come out. Hydrogen gas will come out because of the reaction. For example, zinc and reacts with this is H2SO4 is acid, sulfuric acid. It will give ZnSO4 plus H2.
Zinc.
Hydrogen gas will be formed and this SO4 will connect to zinc instead of H2. ZnSO4 gas will come out. And with base, when it reacts, it will form salt and water. Okay. Similarly, base are compounds which can donate electron, and their properties are they are generally bitter in taste.
Yes.
Bitter.
Yes.
Base. Bitter in taste, and they have a soapy feeling. Soapy means
This.
base.
Like very base, like in acid, vinegar, like base and water.
Yeah, base. And they convert red because of blue. They are electrical conductor only in some conditions when they are in water aqueous solution. This पानी में घुलने पर electrical conductor होता है. And they react with some metals, not all metals. They react with some metals. These are the basic things about base. Then there are salts. Salts are usually formed by reacting acids with bases, so there will be salts. Now, how is a salt formed? In acid, when say there is hydrochloric acid, okay, H plus Cl minus. So when H plus is replaced by some metal, then the resulting thing which is formed is called salt. Say sodium replaces hydrogen plus, then it becomes NaCl. Okay?
So it is salt.
So this is salt, this is common salt. So here HCl is acid plus NaOH is base. They will make NaCl plus H2O. NaCl is salt and this is water. Okay? So like this, when the cation, positive ion, in the acid is replaced by some metal, then the resulting substance which is formed is called salt. So the salts which are formed by combination with chloride, chlorine or HCl, HCl acid से जो hydrochloric acid से जो salt बनते हैं, they are called chlorides. सल्फ्यूरिक एसिड से जो सॉल्ट बनते हैं उसको सल्फेट कहते हैं. नाइट्रिक एसिड से जो सॉल्ट बनते हैं उसको नाइट्रेट कहते हैं. लाइक दैट डिफरेंट नेम्स आर देयर फॉर द सॉल्ट.
Sulfate. We are going in chemistry now.
एसिड सॉल्ट. हाइड्रोक्लोरिक एसिड के साथ जो बने वो क्लोराइड, क्लोराइड्स, सोडियम क्लोराइड, हाइड्रोजन क्लोराइड, सोडियम क्लोराइड, like that, different chlorides. H2SO4, this is sulfuric acid. उसके साथ जो बने उसको सल्फाइड, सल्फेट, कॉपर सल्फेट is one.